Good morning, Amy. How are you doing?
Good morning, sir. Yeah, I'm doing all right. How are you?
Very good, very good. So we have been talking about trigonometry, radian measurements, and we did see how do we calculate the arc length, sector area, the chord length, and composite figures, area, and perimeter of these composite figures, including circles, quadrilaterals, and triangles, tangents, and so many things, right?
Right.
So
Yeah.
that is a very important part for your examination, and I hope you understood most of the questions, examination style questions in that regard. Did you?
Mhm. I did. Yes, I did a lot of exam questions from my book and just past papers as well, and they made sense. And any issues that I kind of had, it was more to do with the wording, not really the actual maths. So that's
Oh,
okay.
okay, okay.
Yeah.
So while going through the book, I hope everything is clear. Are there any doubts?
Yeah. So I was going through the book, and obviously we touched upon like the couple of lessons. It was more to do with circles and circle stuff, and in between a couple of the chapters, there were things about trigonometry,
Mhm.
just some things. So I kind of just skipped that and then went to the circle stuff. But yeah,
What did
do
you
you think we
skip?
could?
What type of questions did you skip?
Yeah, I can show you. It
Sure,
was a
sure,
couple
sure.
of stuff.
Let me share the screen. Yeah, you can actually share, and yeah, yes, you can share, right?
Yeah, so I kind of got like in terms of just these things, I think you just kind of have to know it, but I didn't really touch upon that. But the main issue for me is sine and cos I kind of get if it's in terms of
So which
sketching
question
roughly.
particularly you had difficulty with?
Oh, it was kind of 6 and 7 on six
So
onwards,
can you
basically.
enlarge this question number 6? Can you enlarge
Yeah.
the screen a bit? Okay, let's see. Now it's clear, right? So can you read question number 6, please?
Yep, so sketch the graphs of y equals tan x for x being in between 2 pi and 0, both
Yeah,
included. And then part B, just the same thing with cos x and a
correct. And
different
what is
restriction.
question number 7?
Sketch the following graphs for the given ranges, marking any points where the graphs cut the coordinate axes, and then you've got again, so
Transform
y
function. Oh,
equals,
I see.
yeah,
That's good. So basically, they have jumped from the circles and tangents and arcs and vectors to sinusoidal functions, right? And
right,
this is
yeah,
trigonometric functions, including tangent, sinusoidal functions, sine and cosine. Plus, in question number 7, we're talking about the transformed sinusoidal functions, right?
mm,
So basically, what you need to know or understand clearly is what is the tangent graph? How do we sketch it? What is the sine graph? What is the cosine graph? Correct?
yeah,
And when we do the transformation of these graphs, how could we sketch a graph from the parent tan x to tan x plus pi by 2, for example, correct? So for that matter, any transformation. You see
I
that?
do just want to say before you start,
Mm.
sine and cos graphs are kind of like the parent functions are kind of relatively straightforward in my head, but tan is like there's nothing in my head. I know
First
obviously
tangent.
roughly, yeah,
It
roughly I know
normally
how it
goes
kind of
tangent.
links,
I know that. As the
but
name, right? As the name
yeah,
suggests, that is what it is. So, sure. So, I'll touch upon the basic transformation of sinusoidal functions, which will include sine and cosine, but focus more on the tangent function so that you that tangent is within your grasp. It's not just
okay,
touching and going, right? Is that
thank
okay?
you. Yeah,
I will do
I
that.
like that.
So let me just share the screen. I have something on this. Let's see. Okay, so we'll talk about transformation first to begin with, right? Can you see
Right.
my screen?
Yes, I can.
Right. So what I'm trying to focus on is that sine function is your parent function for any trigonometric function. Let's remember that. And the sine graph actually starts from 0, and that is one full cycle, which I've shown here. And when we are working in radians, the cycle is from 0 to 2 pi, correct? As
Yeah.
shown on the graph. So those are the points. And I did see while going through the questions, they are focusing on few critical points which we should always, and these are called the key points, correct? So as far as the sine x is concerned, we are focusing on the points which are like 0, 0, which from where it starts right there, right? And then the maximum, which is at pi by 2 and 1, the maximum value. Then it comes back and crosses the x-intercept at pi, x-axis, and then goes to the minimum value at 3 pi by 2, like -1, and then gets back to the axis at 2 pi, correct? So these are the 5 critical points which we should consider while discussing sine function. Is that clear to you?
All right. Yeah.
Now, you should also understand why do we have these 5 points, correct?
Mm.
So, we had been talking about sinusoidal functions as circular functions, right? So, let me just make a better circle here, right? So, okay, not that bad, but still okay. So, when you talk about a circular function, that means a point is rotating around a circle. And when
Okay.
it rotates counterclockwise, we say this is positive, right? So this is the angle theta, or you can say x. We'll call it angle theta now. Is it okay?
Okay.
Rather than x, because x-axis is there, so it's kind of confusing at times. So that is the angle of rotation. Right? So let us say we are at this particular position, and this angle is theta for us. Perfect. Let me call this position as x and y. So clearly, what you have here is that the x value is basically, if that is r, in that case, the x value is r cos theta, correct? And the y value is r sin theta, correct?
Mm-hmm.
And if I make r the radius as 1, a unit circle, in that case, x becomes the cosine value and y becomes the sine value, correct?
Yeah.
Clear? So
Yeah.
when you start from 0, y is what? Y is 0. Do you see that?
Yeah.
But as you increase your angle to pi by 2, which is right there, correct? Then the y value is 1, correct?
Oh,
And as you move further, the y value becomes 0.
0.
You can see that. And 3 pi by 2 means minus 1.
-1.
And then it gets back to 0. Correct?
Oh,
Now, think about this as a timeline. You understand? So,
okay.
what I'm trying to see is consider a wheel there. So, as it's moving. So, if the wheel is moving, then this point is also going up and down, right? And it also moves forward, and you get this sine wave. Do you see the sine wave there?
Mm.
If the point is moving up and we are also shifting it right with time, in that case, a wave is formed, and that wave is your sinusoidal wave. Is this clear to you?
Oh, yeah, yeah.
Okay. So that is what sine wave is. And these are your 5 key points for sinusoidal function. As you
Okay.
can see, this function is continuous function, correct?
Yeah.
And it will always oscillate between the values from -1 to
-1
1,
to 1.
crossing axis couple of times as shown here. Correct?
Yeah.
So n pi, the axis will be crossed at n pi, right? So I can say zeros will be at n pi. So every integral value of n, right? 1 pi, 2 pi, 3 pi, 4 pi, it will cross the axis, change the sign.
Okay.
Go to maximum 1, come back to -1. That is how the wave is. Now, the same sinusoidal function, we say sine wave as shown here, but if you consider that what happens to the uh, x value, which is cosine, correct? So
Mm-hmm.
x value is maximum. Do you see x value is 1? When use angle is 0, correct?
Yeah.
So the cosine function basically starts from 1. And then it goes to 0, then it goes to -1, then it goes to 1, and then again back to 1. Is that clear to you?
Oh,
So that
yeah.
is your cosine function. So I'll say cos x. Is that clear? So what has really happened is that the cosine function, this value comes earlier. Do you see that?
Yeah.
It leads.
So,
Yeah.
so with the sine and the cos wave, if you kind of drew them on the same graph, would
Yeah.
it kind of just like
Yeah.
it's
So,
kind of in line with the sine, but not. I don't know how to describe it.
yeah. So basically, the cosine function, I would say, has a phase shift, right? So it is moved pi by 2 to the left.
Oh, I see. Okay.
You get an idea.
Yeah, yeah.
So generally, we say that sinusoidal function parent is sine and cosine is the transformed sine function.
Oh, okay. That
So
makes
is
sense.
this sine function, this is my sine function, it is going up. So you could also write that the cos function has moved right.
Yeah.
If I say cos of x minus pi by 2, right? That means the cos function moves pi by 2 right. You see that? If I
Yeah.
move cos function pi by 2 right, it matches with your sine function.
Sine. Oh. So that equals sine x.
That is sine x.
Okay. Got it. So
So
sine x is the parent function. It's
transform,
like the
yeah.
basis.
Yeah.
Okay.
So the only thing is these coordinate points, y value being same, 0, 1, 0, minus 1, 0, the x values will now be, if you want to start with 0, you'll start with add pi by 2 to it. Is that okay?
Yeah.
Pi by 2. That's what you could do. Or you can consider cos on this side and sine the other side. Either way. Right? So sine, we say cos is leads. Cosine leads. Sine, right? It comes before. Is that okay?
Yeah.
Or we can say sine lags. Cosine. Cosine by pi by 2. Is that okay?
Yeah.
Either way, right? But anyway, this page also shows you the other basic transformations which you are well aware of. So the
Yeah.
idea here is that if we focus on sine function, we actually learn about cosine also simultaneously, right? We
Okay.
don't have to treat them separate. Correct. So that's very clear. Transformation of functions, you remember this kind of a picture which we had also shared with other functions. So for any function, if it is transformed, we could have the vertical stretch and compression, which is decided by the factor a before the function, right? So a gives you vertical stretch and factor. We could write a transform function as, let me write it bigger. We could write it as a sine of, within brackets, k x minus p plus q, right? So basically, these two things which are outside, they stand for vertical transformation, right?
Yeah.
A is for stretch or compression, correct? And q is for translation. Is that okay?
Mm-hmm.
Of course, when q is positive, it goes up. When q is greater than 0, and it goes down for q less than 0. Perfect. And for a, if it is greater than 1, in that case, it is stretch. However, if a is between 0 and 1, in that case, it is compressed.
Yeah.
And if a is less than 0, then means negative, it is a reflection on x-axis, correct?
Mm-hmm.
So that is all vertical. The inside is all horizontal, right? So where k is now the stretch factor, right? So k, let me write absolute value of k. If it is less than 1, in that case, it is a stretch by a factor of 1 by k. If absolute value of k is greater than 1, in that case, it is compressed by a factor of 1 over k. Is that clear?
Yeah.
And if k is less than 0, then it is a reflection on y-axis. Perfect?
Yeah.
As far as p is concerned, it is horizontal translation. If p is greater than 0, then right. And if p is less than 0, then it is left. Right? P units. Is that clear to you?
Yeah.
That is what this transformation is. Now, when we really talk about the sinusoidal functions, they are periodic in nature. They repeat, correct? They are periodic in nature. So, K also gives you the period. So, the important thing here, let me just put it in red. K also gives you the period of the function. Time period, So time period T is basically related with K. So, time period T If k is 2, time period will be 2 pi by, normal time period for a sine wave is 2 pi, right? One full cycle is 2 pi.
Yeah.
But if I have value of k as 2, there will be two waves. If the value
So
of k is 3, three waves within 2 pi. So t is 2 pi by k. So that is how the time period is governed by k.
so does the time not change? Just the number of waves in that time changes with k.
Yeah. So the frequency of the waves change, right?
Okay.
So
So like the
every wave
number of
earlier repeats after one full cycle, which is 2 pi as you saw, right? Initially, one full
yeah,
circle means again the sine wave will repeat.
right.
However, if I go faster,
There'll be
right,
more waves.
it'll
Yeah.
go twice. I mean, double the speed, then there'll be two waves within that, correct? Within
Right.
that
Yeah.
frame of 2 pi. So every wave will be shortened to half, right? If I double
Yeah.
this. So that is a factor k which comes in. You
Mm.
visualize that. Perfect.
Yes. Okay.
So that is what k is. Now, so basically, if you are talking about sine functions, as you can see with these examples, so what I've done here is I've taken the value of a greater than 1. So the green graph indicates the vertical stretch. Do you see that?
Mm-hmm.
If the k a value, the amplitude, which we say in case of sinusoidal function, this is called the amplitude, right? How high it is from the axis. So let me also label, let me add a page here so that I can label a sine wave clearly for you, right? So you should understand what exactly the sine wave is. So let me just make one sine wave, right? And let us say this is our axis, correct?
Yeah.
So let me just write it down here for you. So we call this as the axis. Perfect. And so this is your point 0, correct? Perfect. So this is amplitude. And that is one time period.
One time period. Okay.
Time. Once this is, you can say this is one cycle.
One cycle. Okay.
This cycle repeats, and the period of a cycle is t. Is it clear?
Yeah. Yeah.
If I have a function which is sine of, let us say, x, in that case, time period t is 2 pi. Is this clear to you?
Yeah.
But if I have the function as sine of kx, right, where k is number of waves within this, you understand?
Mm.
So then in that case, the time period is 2 pi divided by k. What I'm trying to say here is something like this. I could have a wave which could be, let me just sketch it. So instead of completing in this fashion, my wave actually comes to the maximum here, 0, minimum, and this point, right? So my wave actually starts kind of like that. You see the sine wave?
Mm-hmm.
So I'll divide this into 4 portions, right? So it goes to maximum, comes to this, goes to minimum, comes to this, right? So we have got two waves now. Do you see that?
Mm.
One wave
Yeah.
from here to this place, then the second wave. This will be sine of
2x.
2x. And the
Oh, so
time
k is
period
2.
for each will be 2 pi by 2, which is equal to pi. Do you see
Pi.
that? This is like pi, and this is 2 pi. Is this clear to you now?
Yeah.
So that is how the wave is. Now, I could also have a wave which could actually shift. Means instead of starting from 0, the wave could start from here. Do you see this?
Yeah. So
It
you
has shift.
moved it
So this is
horizontal
P. This
translation.
is P, the phase shift.
Yeah.
So if I write sine of x, I mean, minus P, then the wave actually starts from here, slightly right,
Yeah.
depending on the value of P.
P. Mm-hmm.
You understand? So that is what the horizontal shift is, and this is how they are related. Well,
Yeah.
the vertical stretch and translation is very simple to understand. It's just standard. The whole axis will go up or down depending on the value of the we have used the letter Q. Is it okay? You understand?
Yeah. Yeah.
So getting back to our diagram, as you can see here, if the value of A is greater, the green line shows you the transform function, it actually stretches, but otherwise it compresses if it is between 0 to 1, and it reflects when it is negative as shown here. Okay?
Right. Yeah.
The K value, if it is greater than 1, that means that we have more number of waves in between, and green, you can see in this particular case, we have shown K as 2.
Mhm.
And then with K as half, only half the wave has come within 0 to 2 pi. So the period for this will be 4 pi. The full wave will be
Yeah.
completed in 4 pi. But if it is minus, it is actually reflected on the y-axis, but it is periodic, so I have shown it similar to this. Do you see that?
Yeah.
Now, p value is a phase shift. If p is positive, it moves right as shown here, but if p is negative, it moves left. The q value is the vertical translation. Being positive, the graph of green goes up, otherwise it goes down. Is that clear to you?
Oh, okay. Yeah.
Now, these transformations you should be applied from left to right. That means stretches and reflection first, translation later. That
Okay.
is with every other transformation, right? So we follow the same principle, correct? I had also talked about sine and cosine wave. Here, there's a neat diagram. So the red color is for the sine x, which you see starts with the origin, okay? And the cosine wave starts with the maximum, shown in blue. So you can clearly see that sine wave plus 90 means left. If I move sine wave left by 90 units, you get the cosine wave,
Yeah.
right? So I have to move sine left to get the cosine. Cosine is leading. Do you see that? Leading. It came
Yeah.
first to 1 before sine, leading. And, you know, so that is the transformation. That is how the sine and cosine are related. Is that clear to you?
That makes sense. Yeah.
Perfect. Now here I've shown you what happens if I do the transformation, right? So what have I done here? I've just translated means moving left to get the cosine wave. Is that clear to you? The only thing
So
is, since I've written in radians, pi by 2,
radians.
instead of
Yeah.
degrees, 90 degrees. Since at this stage, some students are still working in degrees, correct?
Yeah.
Okay.
It's
But
getting
both are,
familiar with the radians. It's quite
yes,
tricky, you know, because we're so used to degrees, sorry.
it is a transition, right? So therefore,
Yeah.
we are going parallel first for some time, but these are standard things which we all know about. Now,
Mhm.
this small table will give you more depth about what you shared with me. You know, the phase shift and all you shared with me, correct?
Yes.
So that is the general equation of any transformed function. Now,
Mhm.
sine is our function. Therefore, we are writing a sine k x minus p plus q. Correct? Now, can you tell me, if I have the sine function as sine of x minus 10 degrees, in that case, what is the amplitude? The amplitude still is 1
Still
because I'm not
one.
multiplying
Yeah.
by any other factor.
You're only doing horizontal translation.
And that too by 10 units, right? Correct? Everything
Yeah.
else remains the same. The period is still 360 degrees if you're working
Mhm.
in degrees, 2 pi if you're working in radians. So you could write anything. You know how to
Yeah.
convert them, correct? Let me write them. Here, 180 degrees is equal to pi. And simple translation, you can do this, right?
Yeah.
Y-axis, I mean, the axis of symmetry is y equals to 0, the x-axis, correct?
Yeah.
Now, if I look into the cosine function in part B, can you tell me what is the amplitude for this?
So would you have a vertical stretch of 2?
That gives you 2 as your amplitude. Perfect. And what is the time period for this?
So cos x normal time period is 360
Yeah.
degrees, but because we've got 3x, which is you said do the
Greater
horizontal
than 1?
stretches
Yeah.
and things first.
Yeah.
So you divide by 3 because it's because you usually do 1/3, yeah, and then and then that's it.
Yeah, that's it. So if you're
Yeah.
working in degrees, the time period for cos of 3x is going to be 120 degrees. Otherwise,
Okay.
it will be 2 pi by 3, correct?
So
So
just
there are 3 waves within that 2 pi or 360.
yeah. Just a quick question. So in
Yes.
terms of time period, the only thing that affects it, is it just the stretches and compressions?
K value, yes.
Okay.
So always remember that time period, if you want to write, time period will be 2 pi by k, right? So k is known from the equation, and so you can write down the time period, correct? If you're
Oh,
working
okay.
in degrees, then it is 360 degrees by k. Is that okay? Depends what you're working with. Is that clear to you?
Right. So
So
because it's only the K value that affects it, then does that mean it's only to
time
do
period.
with horizontal stretches or compressions?
Yeah, inside works on horizontal, right? Outside means vertical
Vertical.
stretches, right? But
Okay.
now, this is a very important equation. Do you see I've written 2x plus 30 inside, right? So I'm writing, this is actually 5, not s. Let me write down this clearly as 5. So if I have y equals to 5 cos 2x plus 30, it is important that you need to factor 2, right? To get the
2.
correct phase shift. You see? So you write this as 2 factored out, you'll get x plus 15. Do you see that?
Yeah. So does that
And
mean K is 2?
k is 2, but the phase shift is 15 left. Is that okay?
Yeah. But so don't accidentally think the space shift is 30
Yeah,
left. Okay.
you have to factor it out as done in
Mhm.
the next question also. But with this, I think you're absolutely clear what is happening to each part when we look at the transform function, sine or cosine. Is that clear to you?
Yeah. Yeah.
Right? So that's what it is. If you want you, so that table gives you all that, but we know we can actually also sketch the graphs of these functions, or if the graph is given to us, we could write it in the equation form. So let us try to do question number 5. Okay,
Okay.
right.
So
So
that
we are
looks
starting from here and we are going up to that place, correct? So time period is what? Let's write down. What is the time period? It is
2 pi.
4, 4 in this case.
Oh. Oh,
Yeah,
you can't just assume. Oh, sorry, I have to use the
just wait.
axes. Okay,
What is
got
the
it.
amplitude here?
Let's say 5.
5 is the amplitude, right? What is the phase shift? 0, as far as the
Yeah.
cosine function. So what is the equation of the axis? 0, right? The axis is also 0, right? Y
Yeah.
equals to 0, right? Because there's no up and down. Do you see? So what will be the equation for the sine graph? 5 is the amplitude, right?
Yep.
Sine of the k value being
4.
so the if time
Oh,
period
sorry,
is
a
4,
quarter.
so k is 2 pi by t. Both are same thing, cross multiply. Do you understand?
Yeah.
Time period is 2 pi by k. Now we have to write the k value because we are doing the reverse backward.
Oh, right.
From the equation, from the graph, we are coming to the equation. So we'll write here 2 pi by 4, right?
4.
We'll simplify, of course. Phase shift is 0, so we'll write nothing here. And that is also 0. So that becomes the equation, which you may simplify and write as 5 sine of
Half
course,
pi.
x or whatever is, let's say x is on this axis, right? Right. So pi by 2
2x.
is that clear to you?
Yeah.
Do you see
Yeah.
how simple it is to get to the equation? Let's try
Yeah.
one more, right? Let's try one more. So this table helps you to neatly lay out and exactly write down what is the equation. Now here again, we have a sine wave. What is the amplitude? You just check the axis, right? So to find the amplitude, let me just push it up a bit. This is your axis. Do you see this axis?
Yeah. Y equals 2.
2, right? So
Yeah.
write y equals to 2 is
So
your
the
axis.
amplitude is 2 as well.
We are going up by 2 units, and the time period is, now you cannot see the whole wave, but you can see the time period of half the wave, which is pi. Do you see that?
Yeah.
If half is pi, then the 2 pi will be full wave time period. Is that
2
clear?
pi.
Correct? There is
Yeah.
no phase shift, so I'm writing here, and therefore the equation will be y equals
Y equals 2
times sine of
sine 2 pi.
2 pi
No.
by 2. Do you understand? So
2.
time period,
Oh, just
let me
pi.
write 2 pi by 2 pi, right?
Yeah.
X within brackets, right? X and phase shift 0, right? So, okay, so that's it. And
Oh,
is that clear?
yeah. So that
Of
just
course, they will
cancels.
cancel. And what you get is the right answer. Which
2
will be
sine x plus 2.
2 sine x plus 2, right? So you can easily, but it's good to write like this, correct? You get the idea.
Mm.
Last, right? Last.
Wait, so just a quick thing. So did
Yes.
you just sub in the 2 pi into the t, because that was the time period, k equals 1?
K equals 2 pi by t, right?
Okay.
So that t was 2 pi every subject.
Just to double check. Yeah, yeah.
Very good. Now, this has a phase shift also. So let's now look at it. Can you tell me what is the axis? So to find the axis, what you could do is you could read what is maximum and what is minimum. Do you see that? The scale is pretty small.
Yeah, sorry, I can't see it.
Now I think you can.
Oh, thanks.
Perfect. Okay, no problems. So it goes from 3 and the maximum is 7, right? So what is the amplitude? So
5.
to find the amplitude, we will do 7 plus 3, or to find the axis, I should say.
Yeah.
Right? To find the axis, let me go back here, smaller one, right? To find the axis, which is the mid value, 7 plus 3 divided by 2. Do you see that? 10 plus 3 is 5. The axis is y equals to 5. Is that clear?
5. Yeah.
So this at 5, we have an axis.
So the amplitude is 2.
The amplitude, now you can very clearly see this is the maximum at 2, right? Amplitude is 2, the axis is 5, but the phase shift, it has moved, right? And this is 3, so this is 1/3. You see the p value, the phase shift is 1/3, right? Right? 1/3, right? Because I have divided, oh, this is 1, sorry. This was 3 in all. Let me just increase the size to you. This is unit 3. Do you see unit 3? So that one is 1, correct? So my maximum. In fact, the sine wave, I should see not the maximum, but sine wave starts from 0, right? So here, do you see that?
Sine wave starts from 0, 0.
0, 0 and goes up, correct?
Yeah.
So maybe in this case, 6, 7, 8, approximately comes to more than 8, 8.5. Because the sine wave is starting, you could say the sine wave is starting like this, because it has to go from 0 up. Do you understand? Or you could have extended this. You could have done that. Is that clear to you? Sine wave starts from 0.
Yeah, I get what you're saying. It's just how do you find out like the numbers and where it shifts?
Read from the graph. This is not a very good graph, but anyway, whatever you read, correct?
Okay, but how do you know if it's right or left?
Oh, you could have seen that side also, but it is not given to you. So what you will do is, to find the time period, you have the 2 maximum, correct?
Yeah.
So this gives you the time period t. This is difficult graph. What is the time period? Can you read from here to here?
11.
1 to?
Oh no, sorry.
9, 10, 11. So it is 10 minus 1 with 9, 11 minus 1, which is 10.
Oh, yeah.
Is that clear? 9, 10, 11, and this is 1. So we
11 minus
maximums, right?
Yeah,
We got the time period. So this time period gives you the value of k, which is 2 pi by 10. Is it okay?
Yeah.
I'm not simplifying, but I'm just keeping it like this. It's better, right? We can always simplify. Don't you worry.
Yeah.
And the phase shift is, since the sine wave starts from here, and we read this value slightly less than 9, it is 8.5. The y value has gone up to 3. Do you see this phase shift? We are starting the graph from here. Sine graph is this graph. Do you see that?
Yeah.
You could take this as a sine graph and then do it. You get the idea.
So if it starts at 8.5, then is that my shift 8.5?
Yes.
Oh. Okay.
Perfect.
So what happened if it was really long? What happened if I saw a sine wave like at 30 or something? Do I pick that?
It could go to the starting point, right? You can actually write down 4 equations for any curve.
Oh, okay.
2 in sine, 2 in cosine. I could have actually extended this and got this point, and I could have got a value which was negative p. Do you understand?
Right. Yeah.
So time period is 10, 1.5 that side.
Got
this
it.
also means This also means 1 point minus 1.5 here. You see that?
Yeah, yeah.
So I could now, let me write down the equation. Everything will become very clear to you for this graph. We'll write y equals to the amplitude, which is how much for us?
2
2 sine
sine
k value
2
pi by
55
10. Let me write pi by 5 now. Correct?
pi 5
Simplify. Right? X.
x.
Now I could write minus 8.5.
Yeah, or plus 1.5.
Yes.
Got
And
it.
I moved up by how many units? 5 units, right?
5, because it's y equals 5.
And I could also
Oh,
write 2 sine pi by 5 x plus 1.5
plus, yeah,
plus
plus
5. Do you
5.
see that? I could also write this as cosine function 2 cos, yes,
Yeah,
pi
4.
by 5. Now, cosine function starts from here. Do you see that? It has moved only 1 unit to the right. So it will be x minus 1 plus 5. The maximum is only 1 unit right.
Oh, yeah. Sorry, I was looking at the maximum at 11.
Yeah, we can see here itself.
Yeah,
It starts from here.
yeah. But you're looking at the 1. I get it. Oh, okay. This
Yeah,
is
you
really
could look here
clear.
11. Yes.
Anywhere, because
That is
that's how
also
the
correct.
course starts. Yeah.
That is also correct. Then you will write x minus 11. You get the idea?
Yeah.
This is
Yeah.
not wrong. I mean, you went one more way where
Yeah.
it's periodic. The key is it is periodic. So you have all those answers. Do you see
Right.
4 questions, 4 equations, right?
Wow.
You see that part? That's what I'm trying to say. You would actually give 4 equations to any sinusoidal function when a graph is given to you.
Oh. I never thought I would be able to find an equation for a graph like that. It looks so complicated, but
This is
it's so
extremely
easy.
complicated.
Yeah.
Extremely complicated. See how easily we just did it in 2 minutes. I
Yeah.
mean, I shouldn't say 2 minutes, but it took us 10 minutes to do all this, right?
No, but yeah, I really understood like every question clearly. Like I now know what to look for and like how to go, because you can't mess up that pattern. You should always look at like amplitude and like look like that for the axes. Don't like go miss and match, because then you're gonna miss things.
So therefore, you have to look very carefully into all these parameters.
Yeah.
Amplitude, period, phase. This is how you have to think. You may put it horizontally or vertically as
Right.
you wish. So when you look into an equation, you have to see. For example, let's do this equation once again. Can you help me, Amy? Write down the amplitude for this equation. There is a reflection also. Do you see that minus, right? So I should
Yes.
say reflection also here. And this reflection is on both x-axis and on y-axis. Do you see that? Because there is minus inside also.
And
Do you
then
see that?
minus. Yeah.
So what is the
Okay.
amplitude in this case? Can you tell me the amplitude?
So the first part, we have to take out the -3
Okay, minus 3. But the
and
period
then
is? Time
factor
period
it.
is 3, right?
Yeah.
And phase shift, you will take out minus 3. So you'll rewrite this as minus 3. Let me just do it here. And x
X
minus
minus
30, right?
30.
All right, we'll assume this to be in degrees. And so phase shift is minus 30 means 30 to the right. So we'll write
30.
only 30 degrees. Is that okay?
Yeah.
If it is left, we'll write minus. As far as the x is concerned, it is not moving up and down. You got it, right?
Yeah.
Once you have all these parameters, you could very easily sketch it, correct? You have to sketch. How will you do? First, you draw your axis, right? So first you draw your
Yeah.
axis. So we'll go
So
for this
0.
axis, which is at 0. Then go to the amplitude, 2/5. Now, for this, I'll make a new scale. When we are working with fractions, I will use 1 unit as 1/5. You understand?
Oh,
I will not
okay.
make 1. I will say 1 is 1/5, 2/5, 3/4. This is my 5/5. Do you understand?
Yeah. Yeah.
This is my 1. This is my 1. I'm making a new scale because I have to draw this. So 2/5 really is this, correct?
Yeah.
This
Because
is
1 unit is 1/5.
yeah,
Yeah.
this is 2/5 for me. You get the idea?
Yeah. Yeah.
So I got my point. 2.5 is my maximum, and 2.5 will also be my minimum. So I'll draw a dotted line. Is that clear to you?
Yeah.
Then I'm saying that my period is 3 units, right? So I have got these 3 units as my period up to here, correct? Period is 3, right?
Yeah. So wait, so how did you get to that? Oh, you didn't change the axes. You kept that the same. Okay, cool.
Yeah, same. I'm just overwriting on it, correct?
Yeah.
At this stage, I will divide my period of 3 units into 4 equal parts. So I'll go at 1.5, divide it to exactly half. Let me do it in a construction line. So because there are 5 critical points, right? This is my one period. Do you see how I'm drawing it? Let me make it
Yeah.
bigger and explain you, right? I have divided into 4 equal parts. So 1.5, and this is like 0.75. Let me just make this point also roughly, right? If you have a good graph paper, because graph paper is nice, but you have to split it into units, which can be easily managed. So I will not write, I'll write like give it proper space. As I
Yeah.
said, the vertical axis, I'll divide 1 unit into 5 equal parts.
How
Let me
come
say
you knew to divide it into 4 equal parts? Where in the question?
no, because I have to make, I am starting my cosine wave with the maximum, let us say, right?
Yeah.
Then the center part, which is the, I have divided 3 into 4, I come to the 0, then I go to the minimum. Do you see how easily I'm drawing it?
Mm-hmm.
And that's my cosine function.
Oh.
I went from,
Okay.
but now I have to incorporate 30 degrees. What phase shift I have? Where is my equation? 30 degrees, right?
Yeah. So 30 units.
Sorry. This 3, I'm extremely sorry. This, I will write 3. What is my time period? Time period is 360 divided by 3, 120 degrees. Where you're working here, right? 360 divided by 3, which is 120 degrees, correct? So this will be 120. Okay, let's redo it. Okay?
Where did the minus go though?
I will redo it. So we will redo it. Don't worry. So again, let's write down the equation. Y equals to minus 2 by 5 cos of, what was it? 3, right?
Minus 3x.
Minus 3x, right?
Plus 90.
Plus 90. So plus 90, we made it minus 30, right?
Oh, you're doing the factorized form, yeah.
Okay, let's write down. So minus 3x, you remember, that's good. Plus 9. Is it clear?
Paying
And what
attention.
was
Yes.
the up and down? No, we are not going up and down. So we'll write this as first step, minus 2 over 5 cos of minus 3 is
3.
common, x minus 30. Is that clear to you?
Yes.
And everything is in degrees, right? Let's put degrees, right? Now, from here, how we are doing it is kind of like this. First thing is, I'll draw the axis, right? So we are saying this is y equals to 0, since this is like plus 0. Let me write here. Is that clear to you?
Yeah.
Then I am checking this amplitude, which is 2 by 5, right? So I'm drawing a dotted line here. This is my way of drawing it. So I'm showing you the most efficient way to draw, which I say is a 3-step method, right? So first I'm just making a frame, right?
Mm-hmm.
So this is like going up from here 2 by 5. Is that okay?
2 by 5 units.
And down 2 by 5, correct? So
Yep.
I have this 2 by 5. I've got these dotted lines, right? Because I know y by, this is y equals to minus 2.5, here plus 2 by 5. Is that clear?
Yeah.
Now, I have a time period t, which is equal to 360 degrees divided by 3, which is 120 degrees, correct? So I'm saying this is my 120 degrees.
How come k is not minus 3 though?
No, minus, k is always positive. Minus means it gets reflected. So cosine function, remember this, cos of minus x is actually equals to cos of x. So because it's an even function, is it okay?
Oh.
Right.
Okay.
So we are just, it stands periodic. So we will actually now take the period which is after the axis. Is that clear to you?
Okay.
So think like this as positive now. Is that clear? Because cos is even function. Is it okay?
Just a quick thing. So if it was sine then, and there
Odd
was a
function,
minus,
you'll go like, yeah. Then it is an odd function. You'll go down.
Cool. Okay.
So we'll just make it because even if it is written minus, it is not wrong. It's correct.
Yeah.
But this is minus. That really means, first, let me make the frame. So I'm saying my frame is from here to there. Is that okay? Within this frame, I have to draw my cos function. I will add phase shift later, 30 degrees. Is that okay?
Yeah.
Now in the frame, I'm saying this is 120. So obviously in my scale, that will be 60, correct? Half of this?
Yeah.
And that will be 30, correct?
30.
It's all approximate, but fair enough for our drawing. Is that clear to you?
Yes.
Cos function minus here means reflection, right? And therefore, I'm going to start from the bottom. And then, do you see how am I going?
Wait, which
Function.
minus did you look at? The minus on the 2/5 or minus on the 3?
So my cos function is now like this. Cos function starts with maximum, right?
Yeah.
Minus cos. So I've drawn the function, this function which I've drawn is minus 2 by 5 cos of minus 3x. I have not taken phase shift into consideration yet because I started from the origin. Is that clear to you?
Yes, yeah.
Now I'm going to shift every point 30 degrees to the right. So this goes 30 degrees to the right. That is my phase shift, right? I mean, you get the idea?
Yes,
And
yeah.
so I have my final curve, which is the cosine function. I made one wave between after 0. Do you see that? And since this is periodic, I can actually go on either side. Do you see that?
Mm.
You get an idea. Perfect.
Yeah, it's really clear.
Not from here, but from here. Is that clear to you?
Mm.
This will go through origin, right? So basically, what have I done? I have actually drawn the cosine function as shown here in 2 steps. How did I do that? I've drawn the axis. That is my step number 1. Y equals to 0. Step number 2, I had taken care of the amplitude, right?
Yeah.
So I got the maximum and minimum. Do you see that? Step number 3, I got a point from the origin to the time period t. So I have this time period t, which is equals to 120 degrees. Do you see that?
Mm-hmm.
So once I have done that, I have divided into 4 quadrants. Why do I do this? 4 quadrants.
Always.
Always a sine wave, circular wave, it goes through 4 quadrants, correct?
Okay. Yeah, because you showed me the circle. Yeah.
0, 90, 180,
180,
270, 360.
360.
Done. You get
Oh.
5 points, correct? So you get these 5 points. Earlier it was these 5 points. 1, 2, 3, 4, and 5, correct?
Yeah.
And then what did we do? We incorporated the phase shift 30 degrees. So we moved those points, right? Do you see that?
Mm-hmm. But the only little thing that I'm still a bit iffy on is that because we were doing the cos function just with the k, I know it says -3 and you said take the positive because of the whole cos minus x equals cos x. So if it was sine and then -3, do you take k as -3? What is sine minus x? Is it minus sine x?
Minus sine x.
So do you have to reflect?
Yeah. So
but then would you reflect again because of the minus?
So it becomes the same thing. Yes.
Oh.
So in this case,
I just wanted to
very
double
good
check
question.
that.
So if I have minus sine minus x, it is minus of minus sine x, right?
Yeah.
Which is sine x. It's an odd function.
Oh, and cos is an even function.
Odd function symmetric about the origin. So if you do both reflection on horizontal and vertical axis, you get the same thing.
Oh.
You get the same thing. You get the idea.
Yes.
Since it is periodic, we can look into any section of the wave. You get the idea.
All right.
But
Got
see,
it.
if the question says, sketch your graph between 0 to 2 pi, sorry, let me not write like this, between 0 to 2 pi, correct?
Yeah.
Now,
Oh,
we have to be specific what comes within 0 to 2 pi because of the phase shift, it is going to change. So the window where you have to block is within 0 to 2 pi. Is that clear to you?
So yeah, restrictions are important.
Sometimes they will add to phase shift 30 degrees, right? For I should not say now 30 degrees, pi by 6, correct?
Yeah.
30 degrees will be pi by 6. So you could add pi by 6 and you can say now. Now the question is, sometimes the question will be, what is going to be the domain of the transform function? So
Oh,
if I should say transform periodic function, one period, one cycle. Then
okay.
one cycle time period will be from pi by 6 to 2 pi plus pi by 6 means 12 plus 1, 13 pi by 6. Is that clear to you?
Yeah.
Then the question will be, what is the domain range of the transform function? Now the domain is going to be from pi by 6 to 13 pi by 6, and range is going to be from minus 2 by 5 to plus 2 by 5.
Yeah. Yeah.
Perfect. Do you understand the transformation of the graph itself?
So with transform, so let's say you had the original graph, and then you had all these transformations that happened to it, like vertical things, and you literally moved it, vertical translations and everything, and compressions and all of that. If you had a set like restriction for the original graph, do you have to make all those transformations to that restriction to get the new boundary, or just the shifts?
Let me explain you. Very good
I don't
question.
know if that made sense.
It makes a lot of sense. Okay.
Oh.
So there are a couple of ways to go about, right? So Emmy, is this cosine function transformation absolutely clear to you?
Yeah, it is. But do you think we could have an example on just the sine function,
Sure.
just to consolidate it?
Yeah. So we have learned with cosine function from the equation, how do we sketch the graph also and incorporate all the transformations. And the method which I discussed with you is basically a graphical method, where in 2 steps we are doing it. Step number 1 is to graph without the horizontal transformation. And step number 2, which is shown here in orange, you see that? Move, including the phase shift, and get the final curve. Is that clear to you? That was a graphical solution. Now, since I'm going to explain you sine function, I will now go with algebraic method. So that'll be interesting. So I'll take up an equation of sine. Let's say we have 5 units as the amplitude sine function, right? And let us say we have 3 waves within a time period of 360 degrees. So, and let's say a shift of 30 degrees.
Okay.
We can also incorporate one unit up, right? Let us say this is our sine function. Is that clear to you? Which we were going to sketch. Now, let me show you the algebraic method. So what we do here is that we actually look into the key values. So for x and y, what are the x and y values and how they are going to get transformed? For sine, the x and y values are 0, 0, correct? 90 degrees, you get 1, right? These are all degrees. And then 180 degrees is again 0. 270 brings it to the minimum value of -1. And 360 degrees is back to 0, correct? Those are the 5 key values. The transformation here is, as far as the x value is concerned, you're dividing by 3 and then moving it 30 degrees to the right. So you add 30, correct? For y, you multiply by 5 and you add 1, correct? You can actually apply these transformations to these points, calculate, and get your answer. You could do these points, correct? Algebraically. So then on a graph, you will plot these 5 points and sketch your curve, correct?
Yeah.
Right. Easy. Now, let me show you graphically how am I going to graph it once again, and then we'll get back to this. So what I do actually is, as I am going to repeat, first is look at the axis. So we have this axis at 1, right?
Yeah.
This is y equals to 1. Then look at the amplitude. Amplitude is 5. So we'll go 5 up from here, right? So this is 5 plus 1. And if you go 5 down, right?
Yeah.
1 minus 5, which is -4, right? On the coordinate, on your graph. Just make this x.
Okay.
What is the time period? So time period for this is, because there are 3 cycles within 360 degrees. So 360 divided by 3 is 120 degrees, correct?
Yeah.
So let us say I make a frame, which, I mean, I'm not using any graph paper, but you can start from 0 and go to 120, correct? To get 1. full cycle of the sine wave, correct?
Yeah.
Divide this into 4 equal parts. 4 equal parts, because if you have got 4 quadrants, right, and 5 key points, starting with 0, maximum at 1, next point, right? So 4 equal parts.
Okay.
Now, your sine wave basically will start from 0, go to the maximum, come back to 0, go to the minimum, and then back to 0. You get a sine wave. Do you see the sine wave?
Yeah, yeah.
So this is the sine wave, which is basically the function y sine 3x plus 1. First step. The second step is to incorporate the phase shift, which is 30 degrees to the right.
Yeah.
Now this is like 60, this is 30 degrees, correct? This is 90. So 30 degrees right means this point shifts and it comes here. So you get here, this point shifts, comes here. This point shifts, comes there. That goes there. And the maximum, the last point goes there. Do you see the sine wave now?
Mm-hmm.
Correct? So now you see if the domain was from 0 to, let us say, 360 earlier, correct? What is the domain now? Is from 30
120.
150.
Yeah.
Because you add 30, so you get 150 here. Is that clear to you?
Right. Yeah.
The range, which was earlier from -1 to +1, is now
The same.
-4 to 6. Do you see that?
Oh, yeah. You're comparing the parent function sine x to this transformed one. Sorry. Yeah.
You get the idea?
Yeah.
I could also find domain algebraically like this. This is much easier, right? We're saying domain is the x value, which is between 0 to 360 degrees, correct? Now look at the transformation. X divided by 3. So let me just divide 0 by 3. We get x divided by 3. And 360 divided by 3 is 120, correct?
Yeah.
And now we'll add 30 degrees. So when you add 30 degrees, you get 0 plus 30 is 30 degrees. Here we have x over 3 plus 30 degrees, correct? And here you have 120 plus 30 degrees. Do you see that? 150?
Oh, so
the domain of the function is between 150 degrees to, from 30 degrees. Do you see that?
Yeah.
Does it all connect? Without doing the graph, you could straight away use this particular calculation algebraically, find the domain of the function. Does it make sense?
Yeah.
Similarly, yeah. Is that
so I was just saying there's 2 ways of doing it. So if one fails, you got the other.
And it all depends. Do you have to graph the function or not? If you don't have to graph the function, go direct.
Okay, got it.
If you have to graph the function, you can see and then write down the value.
Right, yeah.
The range, the y value is between +1 to -1, right? But now our transformation is 5 times. So we'll do -5 multiplied by 5. Is that okay?
Mm-hmm.
And then add 1. So -5 plus 1 is -4, right? Do you see that?
Yeah.
And 5 plus 1 is 6. Didn't we get the range also? -4 to 6?
Yeah, same thing.
So from the transformation, you could actually get both domain and range algebraically, as I've shown. And you have also understood how do we sketch the graph of this function as shown here. Is that clear to you?
Really clear, yeah.
So we'll end our class here today. How do we sketch the sine and cosine function? And we'll take a trigonometric function in the next class soon. Is it okay?
Yeah. When's tan going to come up? I'm not looking forward to it because it's going to be a little bit tricky. Because, I got the stand. If tan's going to be similar in terms of like what we learned today in terms of transformations, it's going to be a little bit hard.
Tan is slightly tricky because tan is basically a ratio of sine and cosine cannot be 0. So that gives you the vertical asymptote, and therefore it is slightly tricky, but we'll look into it with a fresh mind next time. Is that clear?
Okay, yeah. So I'm glad I really understood this though, because the foundation is strong.
Correct. So we did sine and cosine both as you wish. You can try one with the reflection, right? So minus and then bring it down. So can you summarize today's class, please?
Yes. So we kind of started off with, just because I wasn't kind of clear on sketching, especially these sine, cos and tan graphs, because I'm just not used to it. But yeah, so we did start off with just knowing those transformations that we went over like last time, just in terms of vertical stretch and horizontal things. So when you gave that general formula, the things on the outside are to do with the vertical stuff, and then things on the inside is to do with the horizontal. But the main thing that I learned was in terms of drawing. So when you had a, let's say, equation, you have to draw the graph, and we also practice doing it the other way around. So what I learned was this kind of a set order I just wrote down. So like drawing the axes first, that can be a good starting point. Then finding the amplitude to find your maximum and minimum points. And then looking at your time period, so knowing that t equals the 2 pi over k, and knowing k in terms of are you using cos or sine, and if that is, you do know whether to use like -3. If it was a cos one, it's just 3, so it doesn't really make a difference. And then sine, it's the other way around because of their odd and even functions. And then with 4, I said you deal with other stuff like reflections and things, but leave all the horizontal transformations last, because you can deal with that finally. And then we learned to do finding the domain and range using graphical methods, and then algebra.
Perfect. That's great.
So, yeah.
So that's all about it. But I'll take over in details. How do we work with the graphs of tangent? And with tangent, we'll also look into cotangents and reciprocal of sine and cosine. That'll be interesting in the next class. Is that clear to you?
Okay.
So
Yes.
good day for you. We'll end it today, and try some questions from your book. If there are
Okay,
any
will do,
difficulties,
sir.
do let me know. Right?
Yes, thank you so much. It was a really great lesson. Thank you. It really helped
Yeah.
me. So yeah, I'll get on to those and let you know if I have any problems.
Okay,
Cool.
great.
Have a good rest of your day, sir.
You too.